Hi, and welcome back to episode 1. We will continue our exploration of the Elixir programming language and the Elixir programming environment, looking at some of the features and capabilities. In looking for a slightly more robust problem to look at than we dealt with last time, I went to Project Euler. Project Euler has a long list of problems that are sometimes interesting and fun to solve using new programming languages as a way to take you on or force you to go through a tour of those languages, features, and capabilities. In this case, we're going to take a look at problem 1, which tasks us with the job of adding all the numbers smaller than a particular number that are evenly divisible by 3 or 5. So you can see in the case of 10, the numbers are 3, 5, 6, and 9. Add those all up and the number is 23. And so that's our test case. And then we're tasked with finding all of the numbers less than 1,000 that are evenly divisible by 3 or 5. So the way we'll do this is we will start with let me get this font a little bit bigger for us here. All right, that's a little better. So the method we can use to check or the function we can use to check to see if a number is evenly divisible by another is the remainder function, or rem. So you pass in 2 operands, and it returns the remainder of the first parameter divided by the second parameter. So you can see the 10 divided by 2 obviously has a remainder of 0. 10 divided by 3 has a remainder of 1. 10 divided by 4 has a remainder of 2. So you can see this will obviously become important as we take a look at how we're going to implement this. So let's take a look at how we're going to do this. So we'll need to define a module as always. We'll call this EU1. And then we will so since we are tasked with finding the sum of all the numbers that fit the requirements less than the passive number, I'm just going ahead and rather than dealing with 10 and the exclusion that presents us, I'm going to, we'll pass in 9 and deal with that. So the first way first thing we need to do is deal with our edge case. So 0 we know isn't evenly divisible by 3 or 5, so we can simply return 0. And then we can write the next version that we will, so if it's not 0, we'll find this version. And in this case, we can write an if statement. So we can say if the remainder of x divided by 3 is 0, we can do, so we want to, in this case, x is a number we want to add, so I want to return the value of x plus calling find with the next smallest number. In the else case, we still need to check if x is evenly divisible by 5. Obviously need the if here. And then in the else case, so if the number wasn't evenly divisible by 3 or 5, we don't want to add it to the results of calling find with this next smallest number. We simply want to call find with the next smallest number. In that else, in the function definition, let's pop out and see how we did. X, of course, and we're there. And there we got the correct answer, 23, but this is definitely not a very elixir-y approach to the problem. One of the things we can do is we can write a case statement. And in this case, in fact, in the case statement, we could get rid of this version here, and the case does pattern matching just as functions do pattern matching. So we can say if x matches 0, we can say do return 0. And we can say if x matches y. And in this case, we could recreate this nested if, of course, but we've got a pretty powerful feature in the language that's called a guard. So with a guard, what we're able to do is add more specifiers for the pattern matching. So in this case, we can say y is a match for x when y is evenly divisible by 3. So this branch will only get called when the number that was passed into find is evenly divisible by 3, and this version here only when it's divisible by 5. So in those cases, we want to return y plus the results of calling find with the next smallest number. That's true in this version as well. And then we can put a pattern match with no guard. So if neither the prior two match, then this one will match. And in which case we only want to return the value of calling ourselves with the next smallest number. Get rid of all these. And let's see how we're doing. Still getting the right answer. Excellent. So this is slightly more elixiry. But as we did last time, what we want to do is use pattern matching at a function level to do more of the work for us. And we'll end up with functions that are much more compact and much more focused on what we want on each individual case. So just as we used a guard in the case pattern matching, we can use a guard on function pattern matching. So we will say that this version will match when x, and we have to use x here since the variable that's matching is x. So when x is divided by, when the remainder of x divided by 3 is 0, then we will return x plus the results of calling find with the next smallest number. All right, so we will come down here and do the same thing for when x is evenly divisible by 5. Got to change this back to an x. So this should have the same result. So the patterns are matched from top to bottom. So if we pass in a 0, the first one will match. If we pass in a number that's divisible by 3 evenly, the second one will match. If we pass a number evenly divisible by 5, the third will match. And if nothing else happens, we will match down here with the last one, and hopefully the right things will happen. Let's see, we're still getting 23, so that's great. A couple words of advice about guards. One, they're super powerful and they're great to use. Sometimes I feel like as I'm using guard, I'm cheating and having the interpreter do more work for me and I have less work. It's also important to know that not everything is available in a guard. Just because something returns a Boolean value doesn't mean it's available. It's fairly restricted to the mathematical operators, or greater than, less than, equal to. Operators that can identify the type of something, is list, is float, is atom, and a few other functions that are generally implemented as macros in the language. But there is a page on elixirlang.org about I think here in case expressions and guard clauses. So sure, here in 5.2, these are showing a list of all the things that are available in a guard. If it's not in this list, it's not available as a guard, and you'll have to resort to case or conditional or if statement kinds of logic. I've also noticed that things in guards can tend to fail silently, and it gets a little tricky to debug, so it's something to keep in mind. Again, I usually end up using the super hacky io.puts to try and find things out. As the last step in this process, we will solve the problem that we were asked to, which is finding the sum of all the numbers less than 1,000 that are, and let's see, Survey says we got it right. So there you go. We have a pretty elixir-y approach to the problem, and it's generating the right answer as an added bonus. So hopefully that was helpful, and we will continue this next time.